Welcome, ladies and gentlemen, to your very first lesson. Back to the basics, real numbers, and the number line. Now, these are concepts that seem very easy, but they are the foundation of everything we learn. I will guarantee you remember this lesson, or these series of lessons, as the basis of many of your errors in future lessons, in future math classes. So please pay attention. We'll start right now with our problem of the day. Please put these two lists of numbers in numeric order. For the problem of the day, when you're watching our videos, feel free to pause and then come back and watch the rest of the lesson. Let's go ahead and pause right now. And welcome back. Here we go. To understand real numbers and the number line, you understand two types of real numbers, rational numbers and irrational numbers. Rational numbers are numbers that can be written as a fraction. Now, we have up there as an example 5. 5, I know, can be written as a fraction because it's 5 over 1. 1/2 is a fraction. Decimals that end, such as 2.5, that's also a fraction. Technically, it's a rational number. Irrational numbers are things like, and we won't talk about it much here, but you'll see it in geometry, pi, which is a never-ending decimal, or numbers like square root of 2, which does not end either. It cannot be written as a fraction. All real numbers can be found on the number line in numerical order, hence why we practice numerical order for our problem today. You can think of the number line as 2 yards with a fence in between them. On the left side of that fence, you can find all of your negative numbers. On the right side, you can find all of your positive numbers. Dead center is 0. 0 is not positive. 0 is not negatives. I know that some teachers have said it's positive because it doesn't have a negative sign, but think of it this way. If we look at certain combinations of numbers, very specific combinations of numbers, we call opposites. Let's look at 2 and -2. Let's look at 10 and -10. These are opposites. They are exactly the same distance from 0. If I folded this number line in half with 0 at the fold line, these numbers would touch. 0 does not have that. 0 is lone. Okay, it's a very, very sad number. All right, it does not have an opposite, which makes it neither positive nor negative. It's called neutral. Where do we see number lines? Now, this is a very open-ended question. Couple examples that come to mind when I think of this question. We see number lines within time. Time follows a number line. Even if you look at a clock, it is a rounded number line. When it's hot, when it's cold, we look at the thermometer. I almost wrote thermostat. Oops, sorry. Thermometer. There we go. Number line. Again, it can go into negative degrees, it can go into positive degrees, or it can be 0 degrees. When you're looking at a number line, you can read the number line, you can plot the number line. Reading the number line is very simple. Let's look at A. A is directly on the -7. There's my -7. B is on the 0. It's my 0. C is on 7. So C is 7. We're just reading the integers, those counting numbers that you've used probably since you knew what numbers were, these counting numbers, integers. The only difference is we're putting a little bit more emphasis on negatives than you may have seen in the past. On your own, give these next 5 a try. Feel free to pause. And welcome back. A, we had -10. B, -7. C, -3. D is 1. And E is 9. Pretty straightforward. To plot a point on the number line, put a point where you would find the number on the number line itself. Remember to label the point. Alright, so let's go through. Let's pick a different color. Alright, A is at 6, so we just go to 6 on the number line. It's 1, 2, 3, 4, 5, 6 spaces away from 0. And I'm going to label this point, just so I know that that's what I meant by putting the 6 down. A lot of students just put points down and say, yeah, that looks right. You need to label. You need to know that point B was at -3. It's just like labeling a map. Like putting pins in a map. C is at 0. For the next 6, go ahead and pause, and we'll go over the answers when you come back. Welcome back. A, we have 9. B, we have -7. Correct that really quick. That should be A, not 9. Sorry, guys. 10 is C. D is -1. E is 0. So again, that neutral, not positive, not negative, it's neutral. 1.5. Now this one I put on there just to kind of make you think. I'll show you where it is, but it leads us into our next question, our next concept. We're very good at pointing out and labeling these counting numbers, these integers, but everything in between, the halves, the decimals, the fractions, all those points in between, you can also plot. Now, I'm never going to ask you to be exactly perfect. You don't need to pull out your ruler and measure and make sure you're exactly 3/7 of the way across. I'm not going to do that to you. You're going to estimate. Whenever you plot a fraction or a decimal, you need to ask yourself, where is it located? Between 2 points. Well, 1/2. I know that that's smaller than 1, but it's bigger than 0. Is it closer to 0 or 1? It's exactly halfway. Exactly halfway. So A is exactly halfway between 0 and 1. I'm just estimating. -3.8. Now be careful with negatives. The rule with negatives, less is more. The bigger the digit is, the smaller the number is, because the further you're moving to the left. So -3.8 is between between -3 and -4, closer to the -4. So you might see 3.8 and say, okay, well that's a bigger digit, so it's got to be further to the right. Remember, less is more with negatives. Don't let yourself get tricked. It's very easy with those negatives. -2 1/3, that comes between -2 and -3. Now the same thing, 0.8 seemed bigger. I'm using air quotes, bigger. When in reality it was a smaller number. The digit was bigger, but the number, the value of that number was smaller. 1/3 is a smaller, again, air quotes, digit than 0.8. But because it's a smaller digit, means that it's not as negative. So it's closer to our -2. D is 7.75. This is where we can just think normal. 7.75 comes between 7 and 8. Bigger is bigger when you're dealing with positive numbers. So it's going to be closer to 8, because 7 or 0.75 is bigger than half. Really, it comes down to ask yourself, is it bigger than 1/2 or smaller than 1/2? And put it closer to the number where it should be. If it's bigger than 1/2, it goes towards the bigger number. If it's smaller than 1/2, it goes towards the smaller number with positives. All right, go ahead and try the next 6 problems on your own. I'll pause and we'll come back. Welcome back. 0.5 is exactly halfway between 0 and 1. 0, nice and simple, right on 0. That's our neutral friend there. 3 and 2/3 is going to be between 3 and 4. 2/3 is bigger than 1/2, so I'm going to go a little bit closer to 4. Again, not perfect. There's not a whole lot of space, but I can see that that's not 4. I can see that it's not 3. I can see that it's bigger than 3.5, and that is close enough when you're doing something like this. D is -4. Those integers are a lot easier to plot. No thought involved, really. E is 10. And F is 1.5. So it's between 1 and 2, exactly 1/2 between 1 and 2. Thank you very much for joining us. Please give the exit slip an attempt, and I will check it when I see your packet at the end of the week. Your homework is on the next 2 pages. Here you're going to be labeling and plotting points. This assignment, I want you to estimate about where do you think that arrow is. For example, this looks like maybe it's about 1/3 of the way, maybe it's about 1/4 of a way. I would guess maybe 10. Be careful with the ones with the negatives. Thank you very much.